Hello, Mahesh, am I audible to you?
Yes, Shrikant, you are audible.
Yeah, it's clear, no? Yeah,
Yes.
yeah, your voice is also clear. Okay, okay, yeah. I think people are still joining. We'll wait. Yeah, hello. Good afternoon, all.
Good afternoon,
It's been,
Shrikant.
yes, good afternoon, sir. So it's been pleasure again meeting you all for this technology webinar. And our today's topic is with about the ZLD with MVR-based evaporation plant. Now this MVR is the ongoing trend, so we are focusing this webinar on specifically on MVR-based evaporation plant and how we are achieving ZLD by means of MVR-based evaporation plant. So I think people are still joining. We'll wait for another 2-3 minutes and then we'll start our main discussion. So just wait for 2 minutes and then we'll start. Thank you. Okay, good afternoon all. So I think most of the people are joined and other people are still joining, but we'll not wait further and we'll start our today's discussion on ZLD with MVR-based operation plant. I'm sharing the screen and I'll share the screen which give you the clear, more depth into the MVR-based operation plant. So give me a moment. Is my screen is visible to everyone? Sagar sir, can you please confirm?
Yes. Yes, sure.
Yeah,
It's
yeah.
visible.
Okay, okay. So I'll just move forward for the our today's webinar. So our today's webinar topic is about the ZLD with MVR-based evaporation plant. And for this webinar, for because this webinar is a series of our some part of the last webinar which we have conducted on the key concept in zero liquid discharge plant, which we have taken a complete overall overview, of with the all kind of technologies, the overview on the ZLD plant, that may be steam based and the MVR based plant. So this is the second part of that last webinar, we can say that, and along with me. Our Mr. Sagar Wag is there. Mr. Sagar is having 20 years of vast experience into this field specifically. He is having the combination of experience from, say, your production to the complete design engineering and the process engineering part of the ZLD systems and the evaporation and drying technologies. And thank you, Sagar sir, for joining this
Yeah.
webinar with us. Yeah,
Thank you,
and
Shrikant, and good afternoon all.
And
Yes.
once again, as you all know, but still, my name is Shrikant Datir, and uh, I take care of the sales function here with the Shachi Engineering. And our today's webinar, what we are going to cover, because this webinar we have specifically focuses on the MVR based evaporation plant. We have cover all the aspect of the plant, and we will move very fast for the few initial slides, because I have taken the initial slides for the last webinars, so that everyone should get fresh up for the last webinar, and then we can move for the main core on the main core discussion of the MVR based evaporation plant. Okay, so these are the points which we are going to cover in today's webinar. So our webinar objective: Shachi Engineering introduction, the what is ZLD and the need of ZLD, key operation technologies in the ZLD plant, comparison of steam based and the MVR based evaporation plant, overview of. So till serial number 5, this is the content which earlier was also there in the last webinar, but I have put up again here to have the that link and more clarity, so that we can move forward for the MVR based evaporation plant. And from the MVR based evaporation plant point of view, we are covering here the complete overview of the mechanical vapor recompression system, the key components of the MVR based system, MVR compressor working principle, the challenges and the solution in MVR based ZLD plant, common issues generally customer face for the MVR blower and compressors, and how the preventive maintenance also can be done for this MVR-based system, troubleshooting for the MVR system, and again the selection criteria, how to select the right MVR system, and the few parameters are there which are very important while selecting the MVR-based system, while designing the MVR-based system. That also we will highlight here, and the for all our users to get more depth about what kind of the components are there into the MVR-based, MVR blower and compressor, and then the conclusion and the Q&A. We can move forward. So let's dive into the discussion. So as this webinar, the objective of this webinar is that the webinar will provide you the insights on the working principle of the MVR-based principle, the key technologies, and the advantage of the mechanical vapor recompression zero liquid discharge plant. Also, the give you the complete OPEX point of view, transparency with giving the comparison between both conventional and the MVR based evaporation plant. So main objective is to give you the more insights about the MVR based zero liquid discharge plant, so that you can get to know that what kind of what is exactly the MVR, what kind of components are there, what is the selection criteria, what are the problems, troubleshooting. So that is the main focus here. And the last the create an ecosystem that people can learn and grow. So as we are also evolving with the knowledge, we are supplying the systems, so that we want to pass on to the all our customers, all our audience. So let's move ahead. So quick intro about our company. The Shachi Engineering, it's 26-year-old organization and deals into the evaporation and drying technologies. So we do have two business vertical. One is Shachi Process, where we do all process equipments, kind of the dryer, spray dryer, spin flash dryer, integrated fluidized bed dryer, flash dryer, cage mill flash dryer, spray cooler, spray congealing plant, bedding plant. Then the evaporation plant for the product application, that may be falling force. So those comes into the process vertical. The environmental vertical, we do the complete end-to-end solution for the industrial wastewater segment, where it comes with the conventional steam-based multi-effective operation plants, followed by the ATFD, so that we can achieve the ZLD, and then MVR-based operation plant for the achieving the zero liquid discharge. Okay, so this is the quick intro about the Shachi. So, like zero liquid discharge plant, when we say the what exactly the ZLD, in short nutshell, we can summarize that. So when we say any facility is about the ZLD facility. So not a single drop of wastewater should come out from your facility. That is when your facility called as the zero liquid discharge facility. So there are the various means and ways for doing that. So some people do it in-house. Some people, go for the common CATPs for that matter for industrial segment point of view. But now as government has given the mandate that every industry should have the ZLD, and that's what we are also, giving the solutions to our customer that how they can achieve the efficient and reliable ZLD, because this is the most complex plant in their whole facility from the industrial wastewater treatment point of view. The key evaporation technologies. So as we discussed in earlier webinar also, so the main two technologies are there, which we called as, one is called as a steam-based multi-effective evaporation plant. By means we go for the concentration where you need the continuous heat source as a steam or any other heating media for evaporation point of view. And the second one is electricity based, which is mechanical vapor recompression. So ZLD with the mechanical vapor recompression. So this is where we are focusing today, that how we are going to achieve the ZLD with the mechanical vapor recompression, what is the selection criteria and how to go for it. That also will clear. So before moving directly into the MVR-based evaporation plant, just a short brief and the comparison to give you the clear clarity on, and the understanding part from the MVR-based system as well as the steam-based system. You can see on the screen the both kind of system like TVR as well as MVR. The my left hand side you can see that is the TVR based evaporation plant, where the motive steam can be put into the system by means of thermo vapor recompressor, and that continuous heat source needed to the plant for the evaporation. Whereas in the MVR based system, the vapors which are generated from the system, that is again put up into the mechanical vapor recompression, gets again heated up, and then that heated vapor again gives as a heat source to the plant. That was the efficiency we get and the reduction in the OPEX point of view also. So this is just the pictorial representation so that you can get the clear differentiation where the main bucket rest of the other things remain same as it is. There is no such change in the plant configuration and the construction. Only thing is about the heat source and the mechanical vapor compressor implementation. So this is the pictorial representation. If you see in overall point of view that how the plant will look like, the steam-based plant, when we say the ME multi-effective operation plant. So this kind of the configuration of the plant, you see multiple shell and heat exchangers, vapor liquid separators, the preheaters that goes into the concentration, and then the concentration goes to the post evaporation system like centrifuge or ATFD or spray dryer. So that kind of the configuration you can look like. So just give you the overall idea that how the steam-based plant configuration will look like, and similar way that how the MVR-based plant configuration will look like. You can see the lot of equipment gets eliminated, so no multi-effect needed. You can go with a single effect also. Here with the MVR-based evaporation plant, all the quantities of the system get reduced, the pumping system get reduced. So this become very compact design when you go with the MVR. Okay, we'll discuss this on more when we go to the main MVR based discussion, because this is the part of last webinar also that I want to give you one of just brief elaboration on that part, so that you all get the refresh on that particular thing, so that we can move and jump into the MVR based operation plan discussion. So this is the point wise comparison between steam based evaporation plant and mechanical vapor compression plant. Here we given the comparison between triple effect evaporation plant followed by ATFD and the mechanical vapor compression evaporator followed by ATFD. So how it works, that already we have, in pictorial representation, that we have seen that how it works, the way the steam is needed continuously through the TVR, and here the vapor gets compressed by means of MVR. Energy source, yes, high pressure steam is needed for the steam based plant, ME plant, and here the electrical energy for the vapor compression. If the steam is available, you can also use the startup for steam for the startup for the mechanical vapor recompression. So operation cost is higher in here with the ME plant, and then lower into the uh, mechanical vapor recompression plant. So that complete bifurcation with the, say, for capital cost, energy efficiency, steam consumption, electricity consumption, the footprint, this complete bifurcation and the comparison we have given from both the system here, and that we have discussed detailed in last webinar, which was more focusing on the overall ZLD. Now as we are focusing on the um, core on MVR base, so I will move very fastly because we have time constraint also. So I'll move very fastly towards the mechanical vapor recompression design. Okay, here is the before going into the discussion, the brief comparison between the OPEX, where or a lot of customer ask that what kind of the differences you can get into the OPEX on per meter cube cost, or maybe the per kg of evaporation cost with compared to the steam based evaporation plant and the MVR based evaporation plant. So you can see the difference here on kg of evaporation. So around 1.1 rupees of per kg of evaporation cost for the steam based evaporation plant. Here we have considered the comparison between 60 KLD of capacity plant steam base and the MVR base. Okay, so followed by ATFD. ATFD remains the same here. So you can see almost 50% of reduction you can see in the OPEX point of view, where in this OPEX consideration we have considered only the power, steam, and the nitric acid for the CIP, and the hydrojetting once in 3 months. These scenarios we have considered for the OPEX calculation. Manpower cost is not considered here in this OPEX because it's varies based on the customer location, premises, their operating philosophy. No, so that is the variable cost. But considering the main fixed parameter of power, steam, and these nitric acid and the hydrojetting, so this much of difference you can get from the operating cost. But of course, like the main headline generally when when discussion comes on the table for the steam base and the MVR base, it's always like the capex is high for the MVR and the OPEX is low, whereas the vice versa for the your steam base operation, right? So I'll just for you clarity how the OPEX will move on. Later we are typically going to discuss on the MVR based plant only, not on the steam based plant. So yes, here's the overview of mechanical vapor recompression systems. So MVR is thermal evaporation process that recycle heat from vapor. That is the main thing where the MVR is mean and known for. It reduces the energy consumption compared to the traditional evaporator used extensively in ZLD plant for water recovery and crystallization. Then when it comes to the overall plant point of view, what kind of the plant, when you say this overall ZLD plant by means of MVR based operation plant, so there is complete in totality, there are the components. Okay, so Sagar sir, can you just give you more insight on that plant? What kind of totality the plant will look like? What kind of equipments are there? What may be the differences on the equipment point of view if it is there on steam base as well as the MVR based operation plant?
Yes, Shrikant. Thank you. So all audience, before going for the detailed discussion on MVR based system, So I just want to inform you all that the just like multi-effect evaporator, the pre-treatment is very much important in this case also MVR-based system. So you have to means both system are almost similar. You have to do pre-treatment and everything in this case also. So that pre-treatment is also very much important before feeding this effluent into the MVR-based system. Because if you don't pre-treat it, it also create the problem in the MVR system. So that is most important. If you just compare the MVR-based and steam-based system, so all other equipment are almost same. Means the main heat exchanger like calandria, preheaters, then pumps, recirculation pumps, feed pump, everything is remains same. Only the main component in both system is differs is the MVR compressor. This MVR compressor is the core component that compresses the vapor. Whatever vapor generated in the system, it get compressed by the mechanically by the MVR. So what actually happens that electrical energy get converted into the kinetic energy and kinetic energy get converted into the pressure energy. Whatever low pressure vapor is generated, that is get compressed to high pressure in the compressor by mechanically. Just like in the conventional system, it is compressed by using TVR, thermo vapor recompression, with the high pressure steam. So this is the basic difference, and the MVR compressor, that's why is the main component in the MVR system. And other are similar, just like the heat exchanger, crystallizer, ATFD, and all other pumps remain same. So MVR compressor is the key component in the MVR system. Yes, Srikanth.
We can say that it's the heart of the complete plant in that case, because
Yes.
as compared to the steam-based plant, there is not such the equipment which may fail and the plant will stop completely. But here is the catch in the MVR-based operation plant. If your blower gets failed, so you are stuck up with the plant operation then. Yeah. So
and one more thing I want to highlight, means directly starting MVR compressor will not serve the purpose. You have to generate initial vapor in the system, and that is done by either using electrical heater, or by steam. For low capacity MVR system, you can use electricity, but for higher capacities, we have to go for the preheating by the steam. So that is important factor.
That is what we are moving ahead, sir. Like the next slide is about the MVR based compressor and its working principle. So in totality, if you can explain that how basically the MVR based evaporation plant works, and how the MVR specifically covers the operation point of view. So if you can elaborate more on that, so that will be very helpful for all our participants.
Yes. So in this case, initially your feed from the feed tank by using feed pump goes into the preheater. Preheater is the plate heat exchanger, that PHE we generally use for the preheating. And this in this preheater, initially you can use the hot water. Means that hot water is generated by using electricity, by electrical coil. That water is get heated, and that hot water is used for the preheating. And at the same time your blower started, it will create a vacuum in the system, and it will also suck atmospheric air from the system and get heated to the required temperature. So initial 2-3 hours, if you use the steam, it will take around 4 to 5 hours maximum for the preheating and to start the plant to generate the vapor. And if it is electric based, it will take more time for generation of initial vapor. Once that vapors get generated, that vapors gets compressed in the compressor and to the higher temperature and higher pressure. So that hot air or hot vapors with a high pressure, high temperature again goes into the shell side of the calandria, and which heats the incoming liquid in the tubes. So this will started, and you will get the desired concentration in the calandria, and that higher concentration again, just like similar in the evaporator system, other conventional evaporator system, it goes into the your ATFD or centrifuge or spray dryer. So in nutshell, uh, this process working of MVR-based system is like this.
Okay. So can we say that, sir, like if we have the for preheating, so it is better to go with the steam, or it's better to go with electricity? Because see, we have the like as your we have the wide customer range. So few of the customer, okay, they are having the steam, and few of the customer they don't have the steam. But what is the recommendation, ideal recommendation to go for the startup then?
See, as far as operating cost is concerned, it's better to go with the steam. If you have
Okay.
available steam at your facility, so better to go with the steam. Because if you compare the operating cost with the preheating by electricity or by steam, so steam is better.
Steam is better. Yes. Yes.
And you
Okay.
will, and you will also get benefit of initial startup time. Means the initial startup time
That
is
time is
lower in
reduced.
case of steam. Yeah. Yes.
Exactly. And to inform all of our customer and the participant, because anyway, when you go for the ZLD, you need to go for the post-operation system. And if you are implementing the ATFD, anyway for ATFD, you need to give the steam. Or maybe any other, so if thermic fluid is also available, that is also fine. But for post-operation system also you need the steam in that case. So if steam is available, so better to go for the steam then. Right, sir?
Yes.
Yeah. Okay, I'll move forward. So what are the challenges? Like, people are going for the MVR. MVR is the new technology development, gives the, bottom line is that it gives you the low OPEX, and that is what everyone is focusing on. But there are the challenges in the operation of the MVR-based evaporation plant. In totality in the ZLD plant, and itself there is a challenges for the uh, mm, for MVR compressor or maybe blower also. So that we want to discuss here. So Sagar sir, if you can elaborate both point of view, like first on the challenges in plant in totality way and challenges only for the MVR.
Yeah, just like in conventional evaporator or MVR-based evaporator, major issue is of a scaling and fouling in the calendar year. So same like if you don't separate the vapor liquid separation properly, or if your vapor liquid separator design is not proper, in that case there is a chances of carryover in the your MVR blower. So we have to take care of avoiding carryover of particles into the MVR compressor. If you don't design
Okay.
it properly, that entrainment of solid particles goes into the MVR, and it will create scaling and fouling on the blades. So that is very much important. Either you can design it properly, you can add mist eliminator in the vapor liquid separator, or we can have the flash vessel after vapor liquid separator to avoid contamination
Okay.
of solid into the MVR blower. So that is most important, design of the vapor liquid separator. And then is energy optimization. You can integrate this MVR with the steam. If you have available steam in your facility, you can integrate that with the MVR system. Means initially you can go with the MVR system for concentration of up to 20%, and for the further concentration you can use conventional force circulation evaporator by using steam. So that integration can happen, and you can use that. So, and the major issue nowadays is the high capital cost for the MVR based system. If you go with the imported MVR blower, the capital cost is very high. So you have to need to consider the ROI on long term basis. You have to calculate the capex investment and the return on the investment by doing the comparison of OPEX and capex with different type of blower suppliers or different type of MVR system suppliers. So that is most important. And last one is the maintenance. So this is major challenge in the MVR system, that breakdown of the MVR compressor. So the regular inspection, regular maintenance is very much important if you want to run the MVR based plant continuously and to get benefit of a MVR based system of a low OPEX. Yes, Shrikant.
Yeah. So, sir, here about the when you say the about energy optimization and integration, so I feel like MVR is valid when customer is having the surplus power as well as the power is on reasonable rate. If
Lower
power
cost.
itself is costing very high to the customer,
Yeah.
say for example, 12 rupees or 14 rupees of cost, or maybe if the power is getting generated by means of the fuels like LPG
Electricity.
or CNG base, so that power cost itself is go so high, and even the
Yes.
steam cost also. So in that scenario, it's what is your call on that part? If power is available but power is very costly, so what should be the call in that case?
So, Shrikant, in that case, you have to do the actual comparison, the operating cost calculation, the power consumption and the steam consumption. And if
Mm-hmm.
your steam cost is on very lower side, or you have surplus steam, and the power is on a high cost per kilowatt. So if you just calculate it, then in that case, the steam base evaporator is on a lower OPEX value. So in that
Mm-hmm.
case, we suggest to go with the steam base. So
Mm-hmm.
the actual rate of a steam and power is important in that case.
Yeah.
Yes.
Right. And then the option, what you say, I feel that also makes the sense because if it is the combination, say for initial concentration, we can go with the MVR-based evaporation, say around 20-25%, and further concentration by means of forced circulation evaporator by means of steam and like operation. So that also gives the
Yes.
optimum level cost. It's not so low or so high. It gives the optimum range, and plant also can be run on robust way, I feel, right?
Yeah. See, in the market, people are going with the low temperature evaporator. Uh, in that case, the temperatures of the evaporator MVR is on very low side, 60 degrees Celsius or 65 degrees Celsius. So delta T is very low. So with this
Mm-hmm.
available delta T, you cannot go with the high concentration. And because
Mm-hmm.
see, you also need to consider the boiling point rise in the system.
Exactly.
If your
Right.
system is having 5 degrees Celsius of a boiling point rise, and you have available delta T of only 5 to 6 degrees Celsius across the blower, so your heat exchanger will go very high in terms of heat transfer area. And you also didn't
Mm-hmm.
get the available delta T for the required concentration, what generally people goes up to 30 or 40%. So in this
Mm-hmm.
case, initial concentration can be achieved by this low temperature evaporator, that's 60 degrees, 65 degrees Celsius. And further
Yeah.
concentration can be taken care by the forced circulation conventional steam based evaporator.
Conventional
So
steam
that
is okay.
boiling point elevation calculation is also very much important. We generally go with the delta T of 15 degree Celsius. In this case, the 5 degree delta T of boiling point is available for the boiling point rise, and rest of the delta T LMTD is available for the LMTD across the heat exchanger. So in our case, the heat transfer area is on the lower side. And one more important
Mm-hmm.
thing with the temperature is that low temperature is having very low vapor density. With the low
Mm-hmm.
vapor density, the volume of the vapor is very high uh, compared to the high temperature uh, vapor.
Vapors.
In
Right.
our case,
Mm-hmm.
the vapors are at 86 or 80 degrees Celsius. So the volume is on a lower side because of higher vapor density. In case of that lower temperature evaporator, the vapor density is on lower side, so volume is very high. So
Mm-hmm.
the any compressor or blower is basically designed on the basis of volumetric flow rate. So if your volume is very high, so the power consumption required is very high in case of MVR blower, and the model changes with the
Yeah.
volumetric flow rate. So that is
Yeah.
also very much important in the MVR, the selection of the MVR in terms of temperature.
Exactly. Yes. Yeah. Thank you. Thank you for that detailed clarification, sir. I'll move forward for the next slide. So our next slide is focuses on the common issues which MVR blowers and compressors faces during the operations. So our all the maybe the participant which are attending the webinar or a lot of customer which are familiar to with the MVR-based operation, they might relate this slide with their day-to-day operations, and they can relate the this what they should face. So these are the various issues which generally MVR blowers and compressors faces during the operation. So you can just elaborate this in context of the MVR blowers and compressor.
Yes, Shrikant. As discussed in earlier slide, the scaling and fouling is the major issue. Salt deposition,
Yes.
which result into the lower heat transfer efficiency. Then bearing wear and lubrication issues leads to increase your friction and overheating. And
Mm-hmm.
vibration and misalignment causes your excessive wear and impeller damage. Your seal
Yeah.
failures and air leakage reduce your efficiency and increase energy consumption. Electrical control failures, that voltage fluctuation, VFD malfunctions, and surge and stall, that unstoppable flow condition causing damage. Surge is nothing but the lower mass goes, the lower quantity of vapors goes into the MVR, which
Mm-hmm.
results into the backflow of the your vapor, and it reduces the your heat transfer efficiency and the capacity of the plant. A stall is nothing but
Okay.
the lower velocities on the impeller, which also creates problem in the heat transfer efficiency and lowering down of your capacity.
Mm-hmm. Okay.
Yes.
So these are the main issues which generally arises during the operation of the MVR blowers, right? Okay, so as this MVR blower and or the compressors are very precision machine. You rightly pointed out the vibration and the misalignments that straight away gives the damage to the impellers. So one of the major reason what we can say that about this vibration or maybe the which misalignment and linked to the damage of impellers. That also can be linked to the scaling and falling formation, as you mentioned earlier slide. If the carryover is there and if that carryover gets deposited on the impeller or maybe a roots blower, and that deposition can leads to the damage of impeller, right?
Yes.
Okay. So then
So
in that case
you have to
this
do the
design of.
vibration analysis. Yeah. In further, you can discuss in this detail.
Mhm.
What are
Okay.
the solution or what care you need to take for all these
Yeah.
issues.
Yeah. Yes. I'll move forward for the next slide. So from the maintenance point of view, here that we have highlighted these points here about the what kind of maintenance need to be taken care for the MVR based evaporation plant. So can you just elaborate on more detailed point of view on day-to-day routine operation, when customer operates the plant, what kind of preventive activities need to be taken care with the ZLD operation team?
Yes, Shrikant, and this is the heart of the overall operator system. So before breakdown, you have to take care in preventive maintenance. So daily checks is very important. You can check the leakages, abnormal vibration. You can check on daily basis, monitor oil levels. On weekly basis, you can clean the filter, check alignment, tighten the connections. On monthly basis, you can perform the vibration analysis. You can measure energy efficiency. On quarterly basis, you can replace the seals, conduct ultrasonic leak test. Ultrasonic leak test is the advanced NDT test to check the leakages in the system.
Yeah.
It is quite costly, but quarterly you can do this. On
Mm-hmm.
annually, you can replace I mean, you can do complete full compressor tear down, impeller balancing, and heat exchanger cleaning. These are the preventive maintenance you can do in the MVR system on the daily, quarterly, and weekly basis.
Okay. Okay. So
Yes.
what I would like to inform here to all our audience and all participants. So maybe some of are there all already using the MVR-based evaporation plant. See, when we say the MVR-based evaporation plant, it's a technological item, and the plant MVR becomes the heart of the equipment. So my request, all of the customer who are operating the MVR-based evaporation plant or who are going to operate the MVR based maybe if you have any planning to go for the MVR base, this plant needed a very skilled manpower, and this plant has to be with the PLC SCADA system so that the complete monitoring at one go and continuous basis should be there in control room. And for that, you need to have the skilled manpower. If say if you have the plant MVR based operation plant, and if you don't have the sufficient skilled manpower for it, so definitely the problem will get arises because that methodology will not be there. Because once when we do the MVR based operation plan, we do give the complete classroom training to the complete team of our customers so that they can get to know that how the plant operation philosophy is there, how the plan need to be troubleshoot, how the problem need to be identified. That all training we generally provide to all our customers, but for that you also need to have the skilled manpower. So that care has to be taken care by from the customer side. Because if you left this plant to operate on normal level or normal point of view, so that will surely arises the problem. Because as sir highlighted, these daily checks, monthly checks, quarterly and the annuity checks has to be there so that plant can run smoothly and continuously with the required capacities. I hope everyone will get idea about these things and look into that aspect also when you go for the MVR basic operation plant. It's not only the plant supplier's responsibility, but it's a customer responsibility also to maintain the plant operations. The next point which we are going to discuss here about the troubleshooting guide for the MVR issues. So majority three issues generally arises on the MVR. Again, I need to emphasize here, we are specifically discussing all the points related to the MVR blower, MVR compressor. In totality, all the plants, or maybe in totality the ZLD plant, yes, there are the issues which we have already discussed in our earlier webinar also. If you want to have discussion on that part also, you can specifically mention your issues, your problems if you are facing in your ZLD plant, irrespective of any of your capacities in Q&A session when we move to the Q&A session. But as of now, the main problems which generally we identified is that the high energy consumption, abnormal vibrations, and the frequent tripping. Okay, these are the problems during the operations we have identified. So the causes and solution will be more elaborated by the Sagar sir. Sagar sir, please, if you can give more light on this part.
Yes, as Shrikant said, and all knows, these are major problems in the MVR-based system, that high energy consumption. The causes generally are the scaling, misalignment, and poor lubrication of the MVR blower. Solutions are clean impeller, regular places, align shaft, and use correct lubricant. Second one is the abnormal vibration. Generally happens in MVR case. People generally use the acoustic enclosure, but that is not the solution. The causes for the abnormal vibration is bearing wear and unbalanced impeller. So you have to replace bearings, perform impeller balancing is the solution. Then third one is the frequent tripping. So it happens because of the overload, surge, and control issues. So you can adjust VFD, install surge protection system for this problem. Yes, Shrikant.
Yeah. So, sir, frequently this, during our discussion, this bearing point is coming out of during the vibration point of view or maybe wear and tear point of view. So, is it necessary to maintain the sufficient spare for the MVR
Yes.
which relate to the bearing or maybe other parts of the MVR related part? Or is it like
Yes, yes.
we can act upon the failure or kind of things? These are the recommended, spares kind of thing.
Yes, very true, Shikant. It is very much necessary that you must have stock in
Mm-hmm.
spare of a bearing, just like we maintain the seal in case of pumps. So in this
Yeah,
case
yeah,
also MVR, the bearing, mechanical seal, you have to keep in a stock because you don't
yeah.
know when this problem will arises and your system goes into the breakdown. So
Yeah.
keeping stock is important.
So here is the indication for all our customer. Whenever you are going for the procurement of the MVR-based ZLD plan, or if you are having the existing ZLD plan, uh, you always procure the complete plant or MVR system with the spare part list by default. It should not be a let us purchase the MVR first and then go for the spare list later. It should not be like that. You should go for the combination like MVR is known along with the spare itself because that is what the it is mandatory from the critical equipment operation point of view. Yes. So here are the crux of the today's main discussion. Like if MVR based ZLD plant is there, so now there is the vast market like domestic market, the global market. There are a number of supplier of the mechanical vapor recompressor that gives the various type of MVR system. Some gives the root blower, some gives the fan, some gives the compressor, and the various so on. But now the call is from the customer side or maybe for our side also to how to select the right MPR system. So that is the most the always the question arises for everyone that how to go for it because everyone gives the solution by means of their experience by means of the but what are the criteria for select the right MVR. So those points you have specifically highlighted here for all of our customers and the participants clarity so that whenever you comes across such discussion it should be very much clear that whether the given MVR system is right or not. So Sagar sir, this is the
Yes.
main thing where a lot of our customer need more clarity, and if you can give more elaboration on these points, that will be helpful for all of us.
Yes. So till now we discuss about the only the single MVR as a component. But if you look at the overall ZLD system, so any ZLD system, it might be your conventional system or MVR system, the basic remains the same. The basic, like the material balance, is how much quantity of water you want to evaporate, what is your feed, what are its characteristic. So you have to do the basic calculations, basic material balance, and you have to select the proper temperatures so that the scaling will not happen. Generally, we don't go above 100 degrees Celsius to avoid the scaling in the calendar year because in both cases the calendar year remains same. Your feed remains the same. So the basic calculation, basic pre-treatment is very much important. So apart from this, the selection of a proper temperature. As I discussed earlier,
Mhm.
if you go with the lower temperature, in that case, there is the issue of a bigger size MVR, bigger size calendria. So optimize temperature selection is very much important to look at and to optimize your capital cost as well as the operating cost. So it's our suggestion that don't go on a very low temperature side because it results in higher capex and it will also create problem in the heat transfer. So keep optimum temperatures, like you can go with the vapor temperature at 8 degrees Celsius and it compresses up to 100 or 115 maximum temperature on your shell side. So that temperature limitation is very important. And if you go for the higher capacities till 50 KLD, it is okay. Or if you are going for the higher capacities of ZLD like 100 KLD, 200 KLD, 300 or 500 KLD. In that case, you have to check the boiling point elevation on all calendar year. And in that case, this is not possible to go with the single MVR blower. You have to go with the
Mhm.
multiple calendar years or with the multiple blowers to get the required temperature difference across each calendar year. So that temperature selection, then selection of calendrias depending upon the capacities you are looking for is very much important. And as far as MVR is concerned, main is the compression ratio. We can also call it as a pressure ratio. This is nothing but the discharge pressure divided by your suction pressure across the blower. So generally it is in the range of 1 means 1.2 to 1.5 or 1.7. Maximum is 1.7. So you have to take in consideration during the design the compression ratio of your supplier's blower compressor and your requirement of delta T across your heat exchanger. So these two things are very much important: selection of temperature, selection of a blower, because all blowers are not giving the delta T of 15 degrees Celsius or more. Uh, if you are going with the lower capacities, say till 50 KLD, so you can go with the roots blower, that is positive displacement blower, which can give you the 15 degree delta T across the blower. So it is, and the capacities are in the range of 2000 kgs per hour. And
water evaporation.
Yeah. And if you are going for higher capacities, then these root floor are not suitable. So in that case, you have to go for the fan type compressors. But in that case, some suppliers are giving you maximum of 9 to 10 degree delta uh, across the blower. So in that case, you have to go with the two compressors, means 1 plus 1 means 9 plus 9, 18 degrees Celsius. So you have to check the vapors temperature coming out from your last calendria and the temperature required at the first calendria shell. So this is very much important. Some suppliers are giving you the delta T with higher capacities, means up to 20,000 or 25,000 kgs per hour in a single blower fan type. But in that case, the space requirement is very high because it runs on very high RPM. So you have to take in consideration the temperature, pressure, compression ratio, vapor flow rate. Again, vapor flow rate is depend on the temperature and the vapor density, because this is very much important for the model selection of your compressor. And these are the primary things. Then compare energy efficiency and operational cost. So based on this system or your consideration, you can plot the comparison. You can compare different suppliers blower. You can compare multiple effects. Means what happened with the 2 effect, what happens with the 3 effect, what happens with the low temperature, what happens with the higher temperature. So you can plot everything, all options in a single sheet, and you can compare the operating cost and the capital cost. So this is important for the selection of right MVR. Then another thing is the maintenance issue. As discussed, compressor is the heart of the system. So vendor to vendor or supplier to supplier, the maintenance issue varies. So you have to select the right MVR. The supplier who's having the service, after sales service facility in the local areas or your areas. So that is important factor, the maintenance after sales service. Then ensure compatibility with the existing plant infrastructure. What generally happens, see, ZLD system is very old. All industries is having their conventional evaporator system, which is on a steam base. So many industries are now going with the complete change of complete replacement of existing system with the new MVR base, or some are is keeping same calendrias and converting it into the MVR based system with the existing infrastructure. So that compatibility also need to check if you want to replace or fit new system in your existing system.
Yeah. Yes. Right, sir. So, so here also the just one thing, boiling point elevation play any role for the selection thing?
Yes, 100%. Because see, as discussed in our earlier webinar, normal water can boil at 100 degrees Celsius at room temperature. If you put some salt into it, or any salt, and if you heat it, that boiling will happens at, say for example, 105 degrees Celsius. And if you increase more concentration, means if you add more salt, or you evaporate some water, or increase the concentration by evaporating water, that boiling point again get rise. So you require more heat, more temperature. So if you go with any ZLD system, whatever it may be, it might be conventional or MVR based system, the boiling point elevation is very important in selecting the any ZLD system, not only MVR, any ZLD system.
That has to be considered across the heat exchanger so that you can arise your delta T, right?
Yes.
Yeah. So I think that's very important, and that's very important. Yeah, that's very important for all our customers, all our participants to get to know about this criteria. When the customer gives you the temperature profile, you can surely ask them what is the boiling point elevation you have considered in that. You'll get the clarity how much delta T across the heat exchanger they have considered for the evaporation point of view, and you'll get the complete clarity on that aspect also. So that is very well noted point, sir. And it's really a good elaboration on this part ki how to go for the right MVR system. I feel like all our participants must have got the clear idea and understanding about it. And if you have any confusion, you can surely put up your question in the Q&A section when we move to the Q&A. Let us more deep down on the most important thing while designing the evaporation plan. There are 3 pointers which we have identified for the MVR, which is inlet vapor temperature, desuperheating, and the sealing arrangement. Sagar sir, can you please elaborate emphasis of these 3 points on why these points are so important in MVR?
Yes. First point we already discussed, that vapor temperature plays important role in the sizing of the MVR blower. Second most important is the desuperheating. See, when we compress the inlet vapors, it gets superheated. So we don't have actually control on the that temperature of superheating, and that superheated vapors create problem in the heat exchanger. Means it will reduce your energy efficiency, and it cause operational issues. Like is preventing overheating of a heat exchanger is very important. Enhancing heat transfer efficiency means desuperheating helps in all these things, that you can enhance heat transfer, you can prevent overheating, and the protecting of your equipment, the seals and everything. Because superheated vapors are results into damage of the other system. We want saturated vapors, not the superheated vapors.
Not the superheated,
Right. Means superheated vapors has a lower heat transfer capability compared to the saturated vapor, and desuperheated vapor condense faster, means improving your evaporator performance. Condensation of vapors is important for the heat transfer. From your tube, your liquid is coming, and the heat transfer takes place because your vapors get condensed. So if it is superheated, then the condensation is difficult. So we want saturated vapor, not the superheated. So we have to do the desuperheating of these superheated vapors. So this can be done by using, you can either, means this varies supplier to supplier. In some cases, some imported blowers, they provide the desuperheating in the suction of the vapor, means suction of the blower. Generally, the condensate is used for the desuperheating because you have to maintain the same temperature. If your shell temperature is at 100 degrees Celsius, though after condensing these vapors, you get the same temperature. So you can use condensate for the desuperheating in the suction. In some cases, people use the normal water for desuperheating, and the aim is to achieve the required temperature. Means, say for example, your superheated vapor is at, say for example, 150 degrees Celsius, and your required temperature is 100 degrees Celsius. So you have to reduce that temperature difference by using
Mm-hmm.
normal water or by using condensate. So that is
Versus
main
condensate.
purpose. Means you can use either in the suction or in the discharge of the compressor, and this will add to your capacity. Means some 3 to 4% vapors get increase
Get
on the
increased, yeah.
shell side. Yeah, if you add the liquid, means water, for the desuperheating, that water gets in contact with the vapor and get evaporated. So again,
Yes.
it adds to your vapor load on the shell side. So
Got it,
that
sir.
desuperheating is very much important. And third one is the sealing arrangement. See, in any compressor or blower, to get the desired temperature difference across the heat exchanger for the heat transfer, you have to maintain that temperature difference. And that temperature
Mm-hmm.
difference can be maintained by the required compression ratio. If your blower get leakage at some point, you didn't get that compression ratio, required compression ratio, and you get leaks, the required temperature you don't get. So the temperature drops down, and there is no LMTD available for the heat transfer. So sealing arrangement in the compressor is very, very much important. As far these are the important things in the MVR: the vapor temperature, desuperheating, and the sealing arrangement.
Yeah. So these need to be taken care while designing of the
Yeah.
MVR as well as the complete ZLD plant also. Right.
And the
Yeah.
sealing arrangement also varies supplier to supplier. Some uses steam, some uses normal water. It varies.
Okay. Fine. I'll move to the next slide. So, Sagar sir, we need to move little quick because we already
Yes.
crosses the time of ours. So now
Right. Right.
our what main criteria we have highlighted here about the to give the more clarity about the MVR construction point of view, that what are the components of mechanical components of the MVR blower and the compressors point of view. That what we have highlighted here. You can just quickly elaborate it then and we can move to the Q&A session because we have covered up almost all the aspect of the MVR based ZLD plant. So if you can just quickly wrap up this.
Yeah, these are general component, similar like any other compressor. So impeller is there, casing, shaft, bearing, seals, and diffuser. A diffuser is important because it converts your kinetic energy from the impeller into the pressure energy. See,
Mm-hmm.
after compressing, your velocity get increases. So what it means, you want high pressure, not the high velocities. So that diffuser will convert these velocities into the pressure, high pressure. So that is important,
Mm-hmm.
diffuser. And other things are all nose, impeller, casing, shaft, bearing are the common one. These are
Yep.
drive and motor component, electrical motor. VFD is important to play with the speed, the
Yeah.
coupling, and the gearbox. These are the general component.
So those kind of the constructional aspect of the MVR based plant. And
Yes.
I'll move towards the conclusion of the presentation. So in today's discussion, we can say that the conclusion is MVR based ZLD plant is the future of sustainable wastewater treatment because as we are looking forward to go for the energy efficient systems. So MVR is one of the best option when it comes to the industrial wastewater treatment point of view. But yes, there are always pros and cons for the every system. This system also need to be made so much of robust as at compared to the conventional system. A lot of things need to be taken care. Yes, plant need to be operated with the whatever the pre-checks we discuss, whatever the design consideration need to be taken care we discuss. So all those things, if you can implement at one place and then you can go with the MVR-based ZLD plant, surely that is the right choice and right choice for the sustainable wastewater treatment. And the advances in the compressor technology that is also needed because the reputed suppliers all over the globe and the Indian suppliers also, they are going for the advancement. They are researching on this plant and hoping to get the more advantages technology from the suppliers so that the energy efficiency can be improved again more in that context as compared to the present situation. And the integration with the AI and IoT can enhance the monitoring and the performance. This can be the tool now which we will think of it will take place in future MVR-based system, because AI along with the IoT surely play a very key role while the operational and the monitoring point of view and the data data extraction and the data maintenance point of view. This is all needed for that particular point. And adoption of MVR is increasing across the industries for wastewater. So yes, of course, as you all are aware also, now the people are moving throughout to go with the MVR base. Whenever we also get the inquiry, customer always asks us the comparison between the conventional as well as the MVR based plan. We always give our opinion to the customer and the recommendation that considering their effluent analysis, what kind of the system will be the best suited for them. So that generally we give to the all of our customer. If you have also that kind of scenarios, you can surely connect with us and we can give you the complete analysis and the study that what kind of the system should be suited for your application. That we can surely give you. And I hope all of us got the clear, idea and the elaboration. What about the how the ZLD with the MVR based plan can be achieved? What are the critical aspects of that particular system from the operational as well as design point of view? I hope these things are very much important for all of us, and we'll keep sharing all such information. Now it's time to close the presentation. We'll move towards the Q&A session. You can put your questions in the Q&A so that we can take it one by one and we can close the presentation. So my request to all of you, if you have any question, just put up your question into the your Q&A session, please. In chat, there are some question actually. It will be great if you can talk in Hindi. Okay, Pritish sir, next time I'll mix up the things and we will surely conduct English and the Hindi in the combination way. Okay. Hi, for ATMD, do we need stream? This is question from Chamika. Yes, of course, the steam is needed for the ATFD. ATFD is more preferred with the steam only because it's a conduction dryer. And if any other heat source also there like steam or thermic fluid, that also can be used. So that is there. So Pritish Kumar has asked, we have sludge with moisture 65%. How much moisture in steam and power based system reduction is observed? Is this question related to ZLD? Do you mean to Mr. Pratish Kumar? Do you mean to say like this sludge means it's sludge which is coming out of from the ATFD or it's generated from your pre-treatment systems? Because what we are discussing is about the ZLD, and I presume these are the points. Generally, sludge means the solids get generated out of the ATFD only, which is having generally 10 to 5 to 10% of moisture content at the outlet of ATFD. Chemika, yes, is there Q&A? Yes, Q&A session is there. I'm going to the Q&A now. Okay, what is the spare consumption per month value? That can be given, Mr. Pritesh Kumar, based on the case-to-case basis, depends on the plant capacity, model number of MVR, plant things, and the operation philosophy. Surely that offer can be submitted, but it can be given. It's not a vague value generally. Okay, whatever the typical spare list that we also provide will give the total value of the spare requirement. It's not a consumption per month. It's not a consumable. It's as and when required. Generally, when you need, when the failure is there, then you need to go for the replacement. So Chamika asked for the specific energy consumption, electrics and steam. Okay, enough 200 KLD price cosmetic manufacturing plant. Mr. Pritesh Kumar, you really need to think of on the energy point of view. Inquiry should not be work in that philosophy 200 KLD and the price. You need to give us the complete detail and then only the price can be given, because the configuration of plant need to be decided, MOC of the plant need to be decided. That completely depends on your effluent analysis. Nathan Kumar, which kind of industry you can use? Any kind of industry can be used, sir. That depends on the what kind of effluent characteristics of yours that can be given. Can you share the P&I diagram? Chamika asked for this. Yes, sure, we can share you whatever the diagram we have shown in the presentation that we'll share with you. Not an issue. Yeah.
I think Chamika is also having other question. Specific energy consumption, electricity and steam. Chamika,
Ha,
it generally varies scheme to scheme basis, but generally the electricity, it varies in the range of 0.045 to 0.07 kilowatt per kg, and in case of water, I mean in case of steam, it is in the range of 2200 to 2800 kilojoule per kg. But all varies case to case basis, but it is generally the range.
I request all of you to put your question in Q&A session rather than putting into the chat. That will be better. Mr. Vijay Singh has put up the question, sir, that how do you finalize the MOC of any influent? So, Vijay Singh, sir, the effluent MOC can be decided based on your effluent characteristics. That is first point that can be analyzed, and the material compatibility can be checked based on the available data and the past experience. But if not, we can do the coupon test also, and from coupon test data, you can analyze the data whether what kind of the MOC compatibility can be there. Multiple coupon test can be taken and the MOC can be finalized. Yeah. So there are the questions are there. The questions are there. Mr. Dalwani has asked Sagar sir question about the can we use for acid concentration?
I think one more question. What maximum TDS can we achieve by MVR? So it again depends basically initially on the basis of your salt present in the system, means the solubility calculation. And another is your selection of MVR blower. So we can go up to 20, 30, 40%, but it all depends upon your effluent characteristic and selection of MVR blower.
Exactly. Mr. Nathan Kumar asked about, can you explain the selection MVRE once again for better understanding? Mr. Nathan, really time is the constraint, but this webinar, what we discussed completely, it is available on our website in webinar section. You can go through that particular section where we have discussed the selection of MVR, and you can get the complete reback on that part, or you can surely connect with us anytime. We will have a separate discussion specifically on that particular point. Then Mr. Dhirendra Pandey asked about what is the pressure ratio across the compressor, Sagar sir.
As said earlier, it varies in the range of 1.1 to 1.7. Depends upon your temperature selection.
Yeah, that depends on the temperature profile because yes, as Sagar sir mentioned earlier, it's completely the ratio between your outlet to your inlet suction pressure of your vapor. So that
generally
is what the
it is
pressure
1.5, 1.7. In nowadays in the supplied MVR-based evaporator, it is generally 1.7, 1.5.
Yeah, Mr. Dalwani asked about which is better, roots blower or high RPM compressor. Yeah, right. It's good question, sir. It's always the comparison. But like you, as Sagar sir explained during the discussion, there's a limitation from the temperature profile point of view and the vapor flow point of view also. Roots blower can be used for a capacity around, say, when you have the vapor flow around 2000 kg per hour, right, Sagar sir?
In imported, and if you go with the local supplier can give you up to 5000 kgs per hour for the roots blower.
Yes.
Both are better, depend upon your capacity and requirement. Both are better.
Yeah. Pritam Khandale, I think steam consumption for MVR system is little low in OPEX calculation. That steam consumption is for only a startup, sir. That's why it is very low. It's not considered for the continuous operation. But yes, here is the one point which we can add. Maybe Sagar sir also can be at that point, because as MVR plant goes into the continuous operation and it runs on vapors which itself generated into the system, there has to be some losses in the vapor, and to make up that, in worst case scenario, you probably may need to give the little makeup, steam during the operation of the plant also, right, Sagar sir?
Yes, yes. See,
Yeah.
we have to
So
maintain that condition of operation. Means whatever condition we decided for the design, you have to maintain that. At certain point, there is a drop in that condition. So means, steam is again or electricity again need to be added to that required to achieve that required conditions.
Mr. Dhirendra Pandey asked about what type of compressor use. So this is the range what we generally, the compressors are available like roots blower, your fan type, your compressor type, that totally depend upon your temperature profile and the capacity of the plant. Based on that, what we discuss about the selection criteria, considering those points can be given. So yes, for MVR, the centrifugal fan type, the centrifugal compressor type, and the roots blower type, these three types are available in the market. You can go with it based on the requirement. Mr. Dhanwani, can we use for the acid concentration? Acid concentration. Yes, sir.
Means we can use, but in acid concentration, we really need to take care of the material of construction selection
Concentration
in the calendar
completely.
and contact part.
Contact
But
part.
yes, the vapors can be compressed.
Vapor can be
In
compressed. The compatibility need to be checked. When you say the acid, that becomes the such system becomes critical anyway. But a lot of study need to be taken care of. Yes, but it is possible. Akhilesh Chaudhary has asked, sir, can you explain once more the saturated and superated and desuperated stream concept? Okay, Akhilesh, you can also you can refer the webinar on our website. It is available. You can refer that section, and if it is not clear, you can surely connect with us. We can discuss about it. I was bit late in joining. Can you send the presentation, sir? This presentation in this whole video is available in our website. You can get it, which has less maintenance, roots blower or high RPM compressor. Sagar sir.
uh, See, this most important is the selection. Uh, if you choose a right supplier, blower or compressor with a low maintenance, then it's okay. And if you go with the local or low cost supplier, then definitely there is a maintenance. It might be blower or compressor, but generally with a high RPM compressor, the maintenance is higher. But in both cases, you have to take care, you have to do the preventive maintenance. But the high RPM is more the RPM, then there is a chances of more failure. So you have to do preventive maintenance. But yes, it is
Exactly.
high in case of high RPM compressor.
Yeah, we are taking the last two questions. Okay, so now one question is from Mr. Naveen Moria. He has given the two cases. If we have a requirement, case 1 50 KLD MVR ATFD with TDS of 10%, and the case 2 is 50 KLD MVR ATFD with a TDS of 5%. Will the price remain same? Mr. Naveen, actually, price is dynamic. The evaporation rate will be lower down. Yes, price will get reduce with the you can say that with the 10% of the thing, but it's a balance kind of thing. When you are higher TDS, your ATFD size will go on, where the evaporation will come down. But when you have the
Yes.
5% of case 2, where evaporator plant goes size up, but the ATFD will come down. But it will not give us so drastic impact and the difference in the cost that will get reduced. Whatever the differentiation will be there, that will get passed on, but it will not. But frankly, it will not give you that much of difference in both the plant cost.
Yes. See, your ATFD goes double. If you go with the 10% TDS, so compared to the 5% TDS, the post evaporation system, that is ATFD, it will be of a double size. Means in case of 5%, if it is 40 amp square, in case of 10%, it is you require 2, because directly your output get changes.
Exactly. Right. So that is what Som, Mr. Som. Yeah, sorry for the late joining. Yeah, no issue, sir. No issue. Anyway, you have joined the at least Q&A session. You can share your question with our marketing email ID or our personal email IDs also, and you can view this webinar completely on our website. That can be really website and YouTube link you can get on our website. You can go to our website, Shachi, www.shachiengineering.com. You can go to our website. You can get all data. Okay. So one request from our side is that all of our participant, if any of you feel that if you want to have specific discussion or if you want to conduct have webinar or discussion on any particular topic in industrial wastewater segment as well as in the process industry segment where we deals into the like in dryer segment like spray dryer, spin flash dryer, spray congealing. On that context also, if you want to no feel that this webinar need to be taken care on that particular topic, you can suggest the webinar topic anytime to our website, to our emails. Anytime you can email, we can surely take the same in account, and we can try to conduct the webinar on your suggestions also. That also we can do. So you can put your suggestions in Q&A as well in chat also if you feel so. Okay. And really it's been a pleasure always to have such discussion, to have such interaction, to get to know all about these technologies discussion and to pass on this information to all of you. It's uh, we can surely connect for the next month for the new webinar topic that may be for ZLD kind of thing or maybe a process segment point of view. We can surely connect with you and looking forward to all of you to connect again. And once again, thank you, Sagar sir, for the discussion and this detailed information about all the aspect. Thank you
Thank
so
you,
much.
Srikant.
Yeah.
Thank you. Thank you all
So
participants.
yeah, thank you to all participants. Let us connected. Stay tuned with the Shachi Engineering, and we will connect again for the another innovative topic on the webinar, so that all information can be passed, so that our objective that everyone can learn and grow, that can be sufficed and that can be achieved. Thank you so much. We will connected again. Stay tuned with Shachi Engineering. Thank you.
Thank you.